Okay, let's keep going. I think we're at 33 now, right? Okay, let's see this. 33A. Let's see the amount of gasoline a car uses is directly proportional to how much. So when we deal with life applications, we're looking for keywords. So you see directly proportional is a keyword. So when we see this, we think about a formula. Remember, directly proportional means this, right? Means two variables that are directly related. So which means that differ by scalar k. So k is just some number. Just some number. So this is directly proportional versus inverse proportional. Or sometimes we call it direct variation or inverse variation. But whenever we say directly, that means this, y equals some number multiplied by x. Versus later on, probably we're going to see something called inverse proportional or inverse variation. That means x times y equals to k. Or k or y, y equals to k divided by x. So maybe this one makes more sense, right? Comparing to this is y equals to k multiplied by x. But the inverse means y equals k divided by x. Or this one we can write as y divided by x equals to k. So this is y and x in a ratio relationship. Well, here, x and y in product relationship. But anyway, you can remember just either one. So let's see the given data. So this thing, if car uses 8 gallons of gasoline to travel 290 miles, so how much gasoline will it use to travel 433 miles? So we have these three numbers. How do we use it? So let's figure out which one, y and x representing what in this life application. So the first sentence is saying the amount of gasoline a car uses is directly. So that means the gasoline, how many gallons of gasoline, we use y. Directly proportional to how much it travels, so distance, right? So y equals k multiplied by x is the distance. If you want, you could use, G gallons of gasoline, because usually we like to use the initial letter to representing the thing. You can say G equals the K multiplied by distance, right? So how much it travels. So the first given data is in 8 gallons. So if Y equals to 8, we don't know K, but then the car can travel 290 miles. Okay. So this distance, 290 miles. So by this, we can solve for K. So K equals to A divided by 290. So that's our K. Now the question is asking, if it travels 435 miles. So actually, after we have K, we have this relation. We have Y equals to A divided by 290x, right? Because K is 8 divided by 290. Now, X is given as 435. So we have K, which is A divided by 290 times 435. So we just have to calculate this number to get Y. But first, before we do that, let's make sure we understand this question. So first, we're seeing two variables or two quantity in directly proportional relationship. That means Y equals some KX. Then the first condition give us saying if 8 gallons of gasoline is used for the car, then the car can travel 290 miles. So we plug into the formula. That means y equals a, x equals 290. In this case, we can solve for k by dividing 290 on both sides. So k equals 8 divided by 290. Then, so we have this equation y equals to a divided by 290 multiplied by x. Now the question is asking if the car travels 435 miles, how many gallons the car needs. So we just plug in 435 for x. Now we just have to calculate this. First, 8 is an even number and 290 is an even number, so we can divide by 2 for both. Divide 8 by 2, we get 4. Divide 290 by 2, we get 145. Okay. Then 145 can be divided by 5, and 435 can be divided by 5. And if you don't want to do this, of course, you can use your calculator, all right? And for me, I don't like to use calculator. I use the calculator in my head. Okay, anyway. So 5 times 8, that's 40. Then I'm left with 35, that's 7. So 5 times 87 is 435. No, 145 divided by 5, I get a 29. Okay. So 87, 29. Oh, you see this? 3 times 29 is 87, right? Or to see 29 goes to 87 3 times. Remember, we have 4 here. So 3 times 4, that's 12. Okay, so if the car travels 435 miles, it needs 12 gallons of the gasoline. All right, now let's look for B. B is saying 3 friends want to go camping and they pack enough water to last for 6 days. Okay, enough water. We don't know how much water, just enough water. So 3 friends, 6 days. Just as they are about to leave, they're joined by 3 more people, now 6 people. So 3 friends, 6 days of water. Now 6 friends, 6 people now. How long will their water last now? So this just saying, assume the water is still the same amount. We don't know how much water, right? It's still the same amount. So the total days the water supply will last is inversely proportional to how many people go on the camping trip, right? So this is inversely proportional. Sometimes we call it inverse variation. So which means x times y equals x equals k, or y equals to k divided by x. So the first sentence is saying 3 friends, right, for 6 days. So basically we could set up y to be how many people. So if it's 3 people, we don't know k, but it's good for 6 days. So that means k equals to 3 times 6, 18. So that means we have a formula of y equals to 18 divided by x. So now 6 people, right? For how many days? We want to find out x. So x equals to 18 divided by 6, which is 3 days. All right, so this is inversely proportional. We just use the formula of inverse proportion. Y equals k divided by x. Then we look for the data in the question to solve for k. So we did solve for k equals to 18. We plug back into the formula where y equals to 18 divided by x. Now the question is asking if 3 more people now. So 3 originally, 3 more. So now 6 people. We want to find out how many days the water is good for. So it's only 3 days. Right, now let's see 34. 34, we want to evaluate this. We have a square root. And so the trick in here is this -4. Because we know square cancels the square root. But because the inside of a radical sign has to be positive, so we need to evaluate -4 square first. -4 square is 16, positive 16, and is also 4 square. Then we see we have 4/7 square root. So square cancel out the square root. Why? Because the square root we can write as a half, raised by half exponent. So 2 times half is 1. So 4/7 raised by the first power. But when a number raised by first power, we don't bother to write it raised by 1, just by default. So we like to write as a 4 divided by 7. Okay, 35. So we want to find the domain of this function. So we have this 4th root. So the index is this little 4 here. So 4 is an even number, right? Even number changes the negative ones into positive, but this is a 4th root, which means the domain of this. Domain means what kind of value for x works for this function. That means it has to be greater than or equal to 0. If the index is odd, that's okay. The integrand, so inside under the radical sign is called integrand. The integrand can be any number, can be 0, can be negative, can be positive. But when the index is even number, the integrand 5x minus 4 has to be non-negative. Non-negative means greater than or equal to 0. So we have to solve this inequality. We add 4 on both sides, or we move -4 from the left-hand side to the right. Get a 5x greater than or equal to 4. Then we divide by 5 on both sides. So x greater than or equal to 4/5. And sometimes if we, so this is called set notation. If we want to use interval notation, right? We use bracket. We start with 4/5, then goes to infinity. Infinity is just an idea, so we don't use bracket. We use close parentheses. So this is the domain of the function f. Okay. Now we want to evaluate when x equals to 17. So that means, let me write here. We want to evaluate f of 17, which means we just plug 17 for x. So 5 times 17 minus 4. Fourth root. Well, 5 times 17, 5 times 7, 35. 1 times 5, 50, so 85. 85 minus 4, oh, it's a beautiful number, 81. So 4th root of 81. Well, if you remember, 81 is a 3 raised by 4. Right? 3 times 3, 3 square is 9. 9 square is 81. So 81 is a 3 raised by 4. 4 power 4, cancel index 4. So just 3. 3 raised by 1. Well, we don't bother to write a 1. Just write a 3. So f of 17 for this function is 3. So this is f of 17. All right, x equals to 17 means we change the input to be 17. Okay, I need to erase this. Okay, now let's take a look at 36. 36 exponents again. I need to make another pencil. Okay. We have this raised by -3/2. So we have a rational exponent, and now we have a negative rational exponent. So what do? We have a couple of ways of doing it. But first, let's simplify inside first. So look for the same base. Let's look for the base x. So x, when we do division, we subtract the exponents. Minus -5/3. Right, in the numerator, x raised by 1/3. In the denominator, x raised by -5/3. So we subtract those exponents. Minus negative becomes plus. That's for x inside the parentheses. Now let's look for y. Y in the numerator, I have 2/3 minus in the denominator. It looks like y doesn't have an exponent. No, it does. By default, y means y raised by 1. So I just -1 here. Then I still have the power -3/2. So I can add those two. 1/3 plus 5/3. So I have a common denominator of 3. I just do 1 plus 5, which is 6. 6 divided by 3, I have 2. So that becomes x squared. Then y term, I have 2/3 minus 1. Well, 1 is a transformer. Here, it transforms into 3/3. So I get a y raised by -1/3. Then raised by -3/2. So I see inside I have negative exponent. So let's just distribute first. So we do x raised by 2 times -3/2. We distribute this exponent. And the y raised by -1/3 times -3/2. Well, 2 times -3/2, it's -3, right? Because these two cancels the 2 in the denominator. And positive times negative, still negative. So we have -3, x raised by -3. What about y term? Y term will have -1/3 times -3/2. That means positive now. Negative times negative, positive. Then we see this is 3 is in the numerator, this 3 in the denominator, 3/3, that becomes 1. So we just have half. Right? Because you see this is half. And we have 1 in the numerator or 2 in the denominator, that's just half. So how do we rewrite this? Well, y raised by half is the square root of y. X raised by -3, that means x raised by 3 in the denominator. And that's it. So this is our answer for 36A. Okay. 37. We want to simplify this. So the numerator, so we want to write, when we want to do calculation with exponents, we write the exponents in rational exponents. So the power is in the numerator. The index is in the denominator. Same thing for the denominator. So x raised by 3, that's power in the numerator. The index is the 8. Now, when we do division of the same base, we just subtract that exponent. So 7/3 minus 3/8. So how do we do this calculation? Can I change my color? Okay. We just do this. 7 times 8, that's 56. 3 times 3, that's 9. What do we do with those two numbers? This is a minus. So we're going to minus those two numbers. Then 3 times 8, that's 24. So x simplified to be, the denominator is 3 times 8, which is 24. The numerator is 7 times 856 minus 9, which is 47. 47 is a prime number, so this cannot be simplified. If we want to rewrite this, we can rewrite it as x raised by 47. We can break into 24 plus 23, right? Then divided by 24. So we get x times x raised by 23 over 24. Or can write as x 24th root of x raised by 23. In the rational exponent, the numerator is the power and the denominator is the index. So this is our final answer for 37. Now let's see 38. So we want to simplify radicals. We see here we have index 3. We have index 3. And we're multiplying those two radicals because they have the same index. So we can put them together under one index. Once we put them in the one index, we can combine the same base, right? For number, we have 9 times 24. 9 times 24, what is it? But let's just write this way. Let's write the 9 as a 3 square. 24 as a 3 times 8. 8 is 2 cube. So you see 3 cube times 2 cube. So this becomes 6 cube, right? 3 cube times 2 cube. That means 3 times 2 parentheses raised by 3, which is 6 raised by 3. So we have done the numbers. Now, x raised by 11 times x raised by 7, that's x raised by 18. X raised by 18. Then y term, y has no power, means the power is 1. So y times y to the 4th power, that's y to the 5th power. Now let's apply this index, right? 6 raised by 3, power 3, index 3, they cancel each other out, so we just have 6 for the number. Then x raised by 18, 18 divided by 3, that's 6, x raised by 6. And y, 5, so we can split this 5 into 3 plus 2. Y raised by 3, the index 3, that's just y. But then we still have y squared under the cubic root, the index 3. So that's it. This is the answer for A. For B, we have adding radicals, subtracting radicals. In this case, we need like radicals. So we want to simplify. So let's see, 147 can be split into 2 times 7. Oh, hold on a second. No, it doesn't have 2 in it. Oh, I'm thinking 2. Let me erase this. I'm kind of sleepy already. Okay, so 147, we see 7, right? If I divide by 7, I have 7 times 21. 21 is 7 times 3. So that's just 7 squared times 3. So I can write 147 as a 7 squared times 3. 7 square root cancel each other out, right? So that means I have 6 times 7 square root of 3. That's for the first one. So the first one is 6 times 7, which is 42. 42 radical 3. Simplified. Now let's see the second one. 108. If I divide by 2, I get 54. If I divide by 4, I can divide by 4. So I get 2 2 times 4 is 8, so I have 28. 28, that's 7, right? So 4 times 27, that's 108. And 27 is a 9 times 3. So 4 is 2 squared. 9 is a 3 squared. So I have 6 squared times 3. 6 squared times 3, that's 108. So 6 squared square root, I have 6 out, then radical 3. So 4 times 6 is 24, radical 3. So 4 times radical 108 is simplified to be 24 radical 3. Then let's see this one. Oh, you know, about those radicals, right? I made a list. I made a list about the family square root 2, family square root 3, family square root 5 in some videos. Okay, if you have time to watch the video, I've made a list of it. Or you can always simplify like I'm doing right here. So for 75, 75 is 25 times 3. 25 is 5 squared. So when we square root, we get a 5 out, but we have 6 outside. So we have 6 times 5 radical 3. 5 times 6, that's 30. 30 radical 3. Okay, so this is the first number, this is the second number, this is the third number. The first number is addition. This number is subtraction. Right? So I have 42 radical 3 plus 24 radical 3 minus 30 radical 3. So you see everyone has radical 3. So this is called like radicand, like radicals. So that means I can put, it's like a common factor, right? Radical 3 is in 3 terms, like a common factor. So now the first time I have 42 radical 3, but radical 3 is outside the parentheses, plus 24 minus 30 of radical 3. Well, 24 minus 30, negative 6. 42 minus 6, that's 36. So the answer is 36 radical 3. Okay, let's see 39. So I'm going to finish 39, then take a break. Okay. Let me erase this, get a space. Okay, we want to rationalize the denominator. The denominator for this one, we have square root 2 plus square root of 8. What does rationalize mean? Square root 2 and square root 8 are irrational numbers, right? So we want to make the denominator to be integers. Rationalize means make sense of it, right? If we think about 5 apples shared by 2 people, that's fine, right? But if we think 5 apples shared by square root of 2 people, that doesn't make sense because you don't want to see square root of 2 people. That means one person has to be cut and dead. So that's why we don't like the irrational numbers in the denominator. We want the denominator to be rational numbers and ideally to be integers. But how do we change these irrational numbers into rational numbers? Oh, let's make an equal sign. Square root 2 and square root 8 are related. Square root of 8 is 2 radical 2. Right? 2 radical 2. Because 8 is 4 times 2. Square root of 4 is 2. So square root of 8 is 2 radical 2. Well, the numerator, we keep writing it. 1 minus 5 radical 7. Now we have like radicals. We have 1 radical 2 plus 2 radical 2. So the denominator becomes 3 radical 2. The numerator stays the same. Now, how do we change the denominator to be a rational number? We multiply by 1. 1 is a transformer, it is something divides itself, but in this case, it transforms to be square root 2 divided by square root 2. Why we do this? Because square root 2 times square root 2 becomes 2. So 3 times 2, the denominator now becomes a integer. So it makes sense now. Something divided by 6 people. That makes sense for us now. The numerator will have 2 terms. Both has to multiply by square root 2. So 1 times square root 2, that's the square root of 2, minus 5 square root of 7 times square root 2. Well, 5, still 5. But the inside, under the square root, we have 7 and 2. 2 times 7, that's 14. So now the denominator is rationalized. The denominator has integer as, has an integer. Okay, so this is our final answer. The numerator is square root 2 minus 5 square root 14 divided by 6. Let's see B. B will have a cubic root. The index is 3 now. So what do we do? Cubic root 5. Let's rewrite our denominator. 6 is 4 squared, or 2 raised by 4. And the x, let me change my color. Right, I can write it in this case. Now, if I want the denominator, to come off this index, I need to make the exponent to be multiples of 3. X raised by 1, multiple of 3. So what do? I multiply by 1 again. And this one, what I need in the denominator is I need a 2 squared. Because 2 raised by 4 times 2 raised by 2, 4 plus 2 is 2 raised by 6. 6 is 2 times of the index 3. What about x term? X, I need x squared. Because x raised by 1 times x squared, that's x cubed. So 3 is a multiple of 3. So this is what I need. This is what I need in the denominator to be able to rationalize the denominator. But I have to multiply by the same thing in the numerator. Whatever I multiply in the denominator, I have to multiply in the numerator, because I can only multiply by 1. 1 is something divides itself. So when we do this, now you see the denominator will have 2 raised by 6, right? 2 raised by 6 means just 2 squared, which means 4. And we have x raised by 1, x raised by 2, that's x raised by 3. 3, and the index 3, we just have x. Well, the numerator, let's see, we'll have a cubic root of 5 times 4, 20. 20x squared. And that's it. So the denominator is rationalized. The denominator is a 4x now. Doesn't have a radical sign anymore. Okay, I'm going to take a break.